Vantablack retains 99.965% of the light that falls on its ensnaring surface, making it appear as though a wormhole to a remote corner in deep space. But the darkest of them all are the black holes limned by Stephen Hawking in his A Brief History of Time. Even something as elusive as light cannot escape a black hole's sinister pull. To witness this stellar phenomenon in the past, you would need to travel billions of miles away. But not anymore. The British company Surrey Nanosystems has created a material that is the closest thing to a black hole that we'll ever see. The superblack coating is the darkest substance man has ever synthesized. It's called Vantablack. Vantablack, which sounds like a Marvel character, is actually an acronym for vertically aligned nanotube arrays. Black color is not a property of nature, but rather an invention of the mind. The plethora of colors that we find around us are a result of wavelengths stimulating special receptors in our eyes known as rods. However, amongst the different bands that constitute the electromagnetic spectrum, our rods only respond to a few of them. We call this the visible range. If colors are just the absorption and reflection of wavelengths, black and white aren't colors, but rather a representation of absolute absorption and reflection, respectively. An object appears black because it has absorbed all the wavelengths of light incident on it, whereas an object appears white because, on the contrary, it has reflected all incident wavelengths. Vantablack is so dark that it allows almost no incident light to reflect and escape. The National Physical Laboratory in Teddington found that it retains 99.965% of the light that falls on its ensnaring surface. It reflects just 0.035% of incident light. That is phenomenal. Like your friend who promises to have just a single bite, Vantablack doesn't just absorb wavelengths that correspond to visible light. It presumptuously consumes wavelengths adjacent to it, as well. Its prodigious retention also absorbs ultraviolet and infrared wavelengths that our eyes can't even perceive. However, what makes it so powerful in this respect? A forest of nanotubes. The material Vantablack is composed of densely packed carbon nanotubes that are aligned vertically along each other. Surrey Nanosystems described this arrangement as a forest populated by millions of soaring trees. Each tube is around 20 nanometers wide and 14 to 20 nanometers tall, making it 3,500 times smaller than a human hair. The tubes are so compact that a square of 1 centimeter x 1 centimeter bounds at least 1 billion of them. When light enters this dense forest, the space between the tubes brusquely absorbs the light as it reflects and ricochets off them. The light is unable to escape because the tubes are quite tall with respect to their diameter and the space between them. For instance, if the trees populating a forest were 2 to 3 kilometers long, light penetrating the forest from above would find it almost impossible to reach the surface below. Ironically, the carbon nanotubes are grown by subjecting them to light lamps that burn at 430 degrees centigrade. Due to its unique physical properties, light incident on a coating of Vantablack is converted to heat. Given that it absorbs almost 99.99% of light, the conversion of energy is huge. It is this penchant for absorption and heat that led Vantablack to be originally developed for satellites, to soak up the sun shower of light to the last drop. The heat can then be used to, say, power electronics or heat water on a spacecraft. Its high absorption also ensures the reduction of unwanted stray light around high-performance infrared cameras, sensors, and various scientific instruments. To gauge its durability or robustness to guarantee its efficacy in such complex environments, researchers rigorously tested it for elasticity, heat resistance, shock resistance, and vibration. These attributes could revolutionize space and defense technologies, whether through electro-optical imaging or target acquisition systems. Its hypnotizing black color is also utilized by designers and artists to adorn objects and contrive inexplicable optical illusions. In fact, the lack of shades makes even a thick, three-dimensional coating appear two-dimensional. A circular sheet looks like a wormhole to a remote corner of deep space. If you were to reside in a room wallpapered with Vantablack, you would lose your sense of space and time. The beguiling darkness would beckon you to gaze into it, and when you gaze long into the abyss also gazes into you. Thanks for watching. See you on the next one. Oh, and don't forget to subscribe.